So this is about making life easier for data stewards. No explanation needed for this, but we all know we deal with data that there's a pervasive lack of data quality. So we cannot assume anything about the data we're handling, right? We always have to clean it up. And we oftentimes build all these data refineries with all kinds of tooling, uh, special tooling of your choice. But there's this new concept, relatively new concept, of making the whole point of this thing is to make the data fair. For those in the scientific community, this started around 2014, this whole concept of fair data because of the reproducibility crisis in science. So now there's an effort. It was just a talk at a workshop not dissimilar to this in 2014, and it became the fair data principles that is now a global movement. And let me just ask, is everybody in the room familiar with CCAN? Yes, so CCAN quickly is the data portal platform that a lot of the big data portals you get your raw data from use, right? It runs data.gov. All these other national governments use CCAN for the most part. But we are also familiar with the concept of open data as a noun. And we want to introduce the concept of open data as a verb, defined as this: opening the data by making it more contextual, humanizing it, and giving it high resolution, high quality metadata, so it's useful, usable, and used for machines and humans alike. So what we're doing with our work right now, we've been doing open data for the past 15 years. We deployed close to 100 data portals across the US. What we found is as soon as the data portal is launched, there's a lot of excitement. But then shortly afterwards, the maintenance of the data portal starts getting slower because the main complaint is the whole burden of maintaining and grooming that metadata, right? And now with this new data standards, if you're not familiar with the new standards called DCAT3, that's the data catalog vocabulary from W3C. There's a third version that was just published, and it calls for much more than the doubling core metadata fields that we are all familiar with. You know, it's only just 12, 15 fields calling for title, description, owner, license. It calls for much more higher resolution metadata. And the same goes for Croissant. If you're not familiar with Croissant, this is an effort to have a metadata standard targeted to machine learning for machines. And these metadata standards call for even more metadata. So if you are expecting your data stewards who already are having a hard time curating their data corpus manually and ask them to put even more high resolution metadata into their data entries, you're setting yourself up for failure. So what we do in our experience is we need to automate this. So we are creating pipelines where we automatically create the data dictionary, we infer it, we compile summary statistics, we compile frequency tables, we infer a JSON schema, all in the spirit of making it easier for the data steward to do their work, and also producing that context ideal for AI. So this is what we're doing. The main thing that I want to also, we learned a lot of hard lessons, Sammy and I, deploying these data portals this past 15 years, is one thing that we also found is a lot of open data programs are unfunded mandates, right? So it's additional work for the data steward on top of their day-to-day work. So we need to make open data, the act of opening data, relevant to them being able to do their own work on a day-to-day basis, not just to produce an artifact that they need to publish to the public data portal. So it needs to be based on operational data. So this is how we look at it. So the green things is the operational data that's relevant to your day-to-day work. And the yellow and orange things are the things that you share with your partners or to the general public. As you can see, the footprint is much wider at the bottom because you're talking about much larger data sets with PII data, with things that are not supposed to be disclosed, with trade secrets. And you only need to have a subset that you produce and share with your partner or with the general public, right? So it doesn't, right now what happens is this whole exercise of producing the yellow and orange thing is a separate exercise. We want it to be a natural byproduct. Because at the end of the day, the data portal is just a tip of the data governance iceberg. You know, it needs to be coming from the data you actually use. It's not a separate exercise. And also, MAGA for data. Make your data, you need to prioritize your internal staff, right? You need to target the people inside the organization need to find the open data useful for their own work. Because if you do so, high quality open data, the classical open data as a noun, becomes a natural byproduct. So that's why in our deployments now, we often have internal data portal, which we call our FAIR refinery. So in there, we are not just staging data for publishing to the public. We have data for everything that they need to do for their day-to-day work. So it becomes their central source of truth for their metadata. And yep, so this is how we normally do deployments now. So we have an internal data portal. So we don't need to drag data stewards to force them to make good on their data publishing commitments, because they themselves want to open data as a verb on their own because it makes it useful. And hopefully with this dynamic, we can achieve that web of data that Tim Berners-Lee dreamed about, 15 years ago when he wrote about the semantic web. But opening data is typically hard, like I said. This is our experience through those almost 100 deployments, Sammy and I. So we decided, we need to semi-automate it. If you do it the old-fashioned way, it's hard. But if we automate it a bit with the data steward in the loop, maybe we can make it easier. So fortunately, we have a good client in the state of Texas. They funded some user research where they did a survey of all the data portal solutions, including proprietary solutions in the marketplace. And they quizzed some data portal deployments across the US. And they found out that the main complaint the data stewards had was, I need to populate this long metadata form and then upload my data. So they said, no, what you need to do is you need to flip the script, upload the data, and then from that data, infer metadata, which you offer as suggestions to the data steward. And then you have that feedback loop where it's like Copilot, but for metadata. So let me show you a quick example of it. So here's your classic CCAN interface, uploading NYC 311 data. If you're familiar with CCAN, you see this metadata form. So here, I'll pause. You notice here, we flipped the script already. The first thing the steward did was upload the data. So in the background, it's running a process called Data Pusher Plus that uses another open source tool we maintain, QSV, which is very fast because it's written in Rust, it's highly parallelized. For this 1 million, how big is this? For this 1 million row data set, it processes it in a few seconds. And then you'll notice it says it has suggestions for your metadata form. And it started annotating certain things like the description. If you notice, if you're not familiar with CCAN, this is not something you normally see. There's a formula symbol. If the steward clicks on it, well, this is a dummy one. It computed the latitudinal range. Basically, this is just a min-max range of the latitude, but it inferred what the latitude is, even without you telling what the latitude field is. It inferred it using heuristics. And here's something more relevant. Here it inferred the spatial extent. It inferred automatically looking at the columns of the CSV. Oh, this is the latitude because it's in the range of the field, and then it created this automatically. Okay, and so on. Here, description. Using an LLM, it inferred the description, which you can also, of course, that's meant to be edited, and so on. So we have all these formulas that you can use to infer all these formulas. So that's one. This is we call it the draft. Another thing that we did is, because a lot of the metadata properties they call for are spatial and temporal metadata, if you're used to CCAN, you have to enter that manually. Now we made it more modern. As you can see, we built this for Texas, but we'll open source this soon once we generalize it. And the thing that I was telling you about, that was doing all these suggestions, we have a tool that we use. We call it QSV. It's another open source tool, and we have this command, describe GPT. And what it does, it infers the data dictionary, description, and tags, and it also allows you to chat with your data. It does that by compiling summary statistics and frequency tables, and then sending that to the LLM with some prompt guidance. And the beauty of this approach is we call it a zero copy approach, because even if I have that 1 million row sample I told you about, that only produced 50 kilobytes. That includes the summary statistics, all 41 columns and 40 columns, so that's 160 cells. And then the frequency distribution of all those 41 columns, the top 10, and then the detailed prompt guidance, 50 kilobytes, and then send that to the LLM. So that's the good thing with that approach is you save on your tokens and you keep your performance. And now with local LLMs, some people might say, hey, your statistics will leak PII information. Yes, because it's statistics. But then if it's running, you're sending it to a local LLM, it's me, right? So they're not training on your data. And what we do is, if before we were only inferring the data dictionary description tags I showed you earlier in that form, but now what we're going to do and release in the next version of Data Pusher Plus is the ability to chat with the data. And let me show you quickly how it's done. So here, I know this is too small. We use the describe GPT command and ask it to prepare a data dictionary description and tags. And you can see it by default, it creates a markdown file. And this goes directly to the CCAN data dictionary. It prepares a draft description with notable characteristics. Because we told the LLM, oh, you're an expert data scientist. You're an expert information scientist. And you're expert. And then it created all these observations that is useful for the data steward when they curate their data, right? And that's for the data dictionary. And chatting with the data, here I asked the question, what are the top 10 complaint types per community board and borough? So we prompted the LLM, if you cannot answer the question using just summary statistics and frequency tables, create a SQL that can answer this question. And the beauty of that is, since SQL is a language and LLM, L is language, it's very good at creating draft SQL. And 9 out of 10 times, it creates SQL that runs. And when it runs, it's hallucination-free, right? It's reproducible, it's deterministic results. So yeah, and here, we look at this very complex SQL that came from that query. You know, it was doing a union and joins and everything here, and then it told you the reasoning, how it arrived at that SQL statement. And then you can even, if the SQL statement runs, it shows you the answer. So one more thing before I go, is now that you have all these high quality metadata in your catalog, what else can you do with it? Well, you cannot just chat with that one data set. You can then chat with your catalog, right? So now we can chat with our catalog. So I don't need to explain to you what's happening here. We use the same metaphors that you're familiar with, that you've been trained to do with Claude, with ChatGPT. We didn't want to reinvent anything. Here we're using Claude. And the thing here is, one thing I do want to, specific to CCAN, oh, it's not showing it right now, is we show our work. If you click on the data sources use, it will show you the resources, the CCAN resources, where they came from. And then this will, when we release it, this answers will be Jupyter notebooks. So you can run them as artifacts that you can then tweak in for people to use. So with that, I'll open so wrapping up, so CCAN is not just for open data as a noun, it's also great for opening your data for your day-to-day use. Thank you.
We have time for one quick question.
My question is, how is it implemented, the zero copy approach there, if you have an exact implementation?
Yes. So like I explained earlier, so we've been using a lot of local LLMs. And what we do is we profile the data set by compiling summary statistics with that tool called QSV. And we compile a frequency table also using QSV. And we send them quickly. Let me show you. So here is let me make this bigger. How do I make this bigger? I am not used to the keyboard. There you go. So here we give it guidance. There are replaceable parameters, stats, frequency. These are replaceable parameters. And here's the system prompt. You're an expert library scientist, blah, blah, blah. Here's the summary statistics. Here's the frequency distribution. And then we prompt it. Like here for the answering to SQL. Here you go. We need to answer the user's prompt above, think step by step. If the question is not about the data set, don't answer. If you cannot answer it using summary statistics frequency, create SQL.
Okay.
Right.
Thank you. Thank you, Joel.
Thank you.